Assalamualaikum and good morning to Petrus. My name is Muhammad Dinish Lukman bin Norisham, number metric 07 DKM20F2056, and today I'm going to talk about combined power cycle. Demonstrate the concept of combined power cycle. The gas turbine engine is used to create electricity by using the Berton cycle, compressing air, combining it with fuel, igniting the fuel air mixture, and expanding the heat vaporized via the turbine to create power are all part of the process. The Rankine cycle, on the other hand, is a thermodynamic cycle utilized its steam power plant to create energy. It works by boiling water to produce steam, which is then expanded via the turbine to produce power. By combining these two cycles, the discharge heat from the gas turbine cycle may be used to create steam for the Rankine cycle, increasing the overall efficiency of the power generation process. The hot exhaust gases from the gas turbine cycle are used to heat water in a
My name is Muhammad Najwan Bizanuddin, metric number 07 DKM20F1032. Now I will explain about the purpose of combined cycle and its layer. Combined cycle power plants are designed to increase efficiency and reduce emission compared to traditional power plants. They achieve this by combining two thermodynamic cycles, the Brayton cycle and Rankine cycle. In the first stage of process, a gas turbine is used to combust fuel and generate electricity through the Brayton cycle. The exhaust gas from the gas turbine is then used to produce steam through a heat recovery steam generator. In the second stage, this steam drive a steam turbine which generates additional electricity through the Rankine cycle. The combined cycle layer include the gas turbine, HRSG, and steam turbine. The gas turbine and HRSG are usually located on top of each other, with the HRSG recovering waste heat from the exhaust gas of the gas turbine. This waste heat is then used to generate steam for the steam turbine. The benefit of combined cycle power plant include more efficient fuel usage and lower emission, as the waste heat from the gas turbine is used to produce additional electricity. This design also allow for flexibility in fuel source, as the gas turbine can use a variety of fuel such as natural gas or diesel.
My name is Bill and I'm going to present about demonstrate combined cycle working principle. The first step is air is compressed by the compressor and sent to the combustion chamber. And then fuel is added to the compressed air in the combustion chamber, creating hot exhaust gases. The exhaust gases are used to drive the gas turbine, producing mechanical energy. The mechanical energy is used to power the electrical generator, which producing electrical energy. The exhaust gases are sent to the heat recovery steam generator, which is HRSG. The exhaust gases transfer heat energy to water in the HRSG, producing steam. The steam drives a steam turbine, producing additional mechanical energy. The mechanical energy is used to power the electrical generator, which producing additional electrical energy. Then the steam is sent to the condenser, where it is cooled and turned back into water. Lastly, the water is then sent back to the HRSG to restart the cycle. Next, I'm going to explain the advantages and disadvantages of combined cycle. The advantages is higher efficiency. The combined cycle power plant uses the Rankine cycle and the Brighton cycle to attain greater efficiency than a conventional power plant. The gas turbine's waste heat is recovered to produce steam, which then operates a steam turbine to generate additional electricity. This means that more energy is extracted from the fuel, leading to increased efficiency and decreased operational costs. Next is flexibility. Due to the presence of both gas turbines and steam turbines, it can be rapidly ramped up to meet peak demand and then derated as demand decreases. This adaptability allows it to provide electricity on demand and assure grid stability. Lastly is lower emissions. Because the combined cycle power plant is more efficient than conventional power plants, it emits less greenhouse gases such as carbon dioxide and nitrogen oxide. Next is disadvantages. The disadvantages is high cost and high maintenance costs. This is due to HRSG can be difficult to maintain due to their elevated temperatures and pressure. Lastly is water usage. For cooling purposes, the combined cycle power facility requires a substantial quantity of water. It employs water as a coolant for both the steam turbine and gas turbine.
Next is question 2. Analyze the diagram for different gas turbine system equipment layout. First, determine the schematic flow process diagram. So in this diagram, we have intercooler, regenerator, and reheater combined in combined cycles. A combined cycle power plants use fuels to drive gas turbines which generate electricity. The hot exhaust gas from the gas turbines is cooled in an intercooler, being reheated and used to generate steam in a boiler. The steam drive a steam turbines which also generates electricity. The exhaust gas is then passed through a regenerator to recover some of heat and further increase the efficiency of the process. The use of intercooler, reheater, and regenerators in the combined cycle power plants allows for better heat recovery, increased efficiency, and improved power output. That's all for us. Next, I will pass to Najwan. Thank you.
Then, the diagram above shows the change of temperature and entropy in gas turbine power plant with intercooler, regenerator, and heater, while the diagram below shows the change of pressure and volume in gas turbine power plant.